Morning, guys. I've got a little project here that I'm going to work on. If you can see this shaft right here, I want you to watch it. Try to get in on that. And you can see the side-to-side movement on it. Yeah, it's just a steel shaft riding on bare cast iron, and that's a rack and pinion. That's the shaft for the pinion gear. It rides on that rack underneath the bed on a lathe. You can see the pinion gear in there. Now this little bit of slop is inconsequential to threading and turning, because all you have to do is take up this little bit of slop on the hand wheel, take up this little bit of slop before engaging the feed, and it's all about learning to use machines that are old and have play in them and things like that. But I think we're going to get a little anal with this, and we're going to do a bronze bushing in there. Now I did bore out the lead screw. That was a steel on cast iron bearing surface, and it was getting sloppy. The cast iron was getting hogged out. So I pulled the lead screw out, polished it, and bored the housing, and pressed in a bronze bushing. And I actually drilled a hole that lines up with this oil cup here. So when you put a few drops of oil in there, it'll migrate out into the bearing. So we've got a bronze bushing already there. I rebushed the other end of the lead screw inside the gearbox in there. That's got a fresh bushing in it. So the lead screw's running tight and straight. And a slight improvement to the steel to cast iron contact there. But this gets an awful lot of use. So I'm going to take that and get a bushing in on both sides of this carriage. I'm going to pull the carriage out. The carriage is in right and left halves. And then we're going to bore that. I believe that's a 5/8 shaft. Bore it out and get a bronze bushing in there. Hi guys, we're back on the bench. And here's the shaft that's in question. This is the front side, or this is the back half of the apron, and that's the first part of the shaft that you saw in my first little bit. And it's got a rear support here, and this is the front support that you saw from the first video. And this is actually where the hand wheel goes. So I was just going to show you what kind of run out I'm getting in this thing. I've got the shaft in there all set up the way it was originally installed against the cast iron. So, I mean, I'm trying to get in on that indicator. You're about 7.5 thousandths below, and then I'm going to push on the shaft the opposite direction, and it goes all the way around the scale and almost right back to where it started. So this is huge. That's a hell of a lot of wear right there. So what we're going to do is, I've already made the bushing for it. This is just a little oilite bushing. And I'm going to get this on the mill and get it set up and indicated on that hole, and open the hole up until that bushing presses in. And the thing about bronze bushings, it's kind of neat. If your shaft is a little scored and undersized, and you polish it up, and then you obviously lose dimension. But when you take a bronze bushing, you can go all the way up to about a 4 thousandths crush fit inside of a hole. So you make your hole 4 thousandths less than the OD of this bushing, and then when you press it in, that bushing actually compresses. It puts a radial load on it, and it compresses down, and it'll shrink down the shaft. Now if you get it too tight, don't worry about it, because you can always run a reamer or polish the inside of the bushing after it's pressed in till you get a nice tight fit. But that's kind of neat about bronze bushings, and they're self-lubricating. This has already been cut to length and bored to size. And it fits on the shaft, but it's got about a 1,000 slot fit. And we're going to try to get it down to a 0 clearance, and then there'll be a run-in period where the machine will be very tight when it's in operation. Then everything's going to loosen up and run real slick for many years, hopefully. And these bushings are easily replaced. Just pop them out on an arbor press and stick some new ones in. But anyways, I'm going to be bushing here. This is the back side. That's the pinion gear in there in the back, and the pinion shaft. And here's the front side that's off the pinion, and then the hand wheel goes on here, and the hand wheel is very loose too. So I'm going to bush this as well. This is a pretty long boss that's cast in there. So, and it's got a ball oiler right there in the center. So actually I'm going to do two bearings. I'm going to push one in from this side and one in from the back side, and leave a little gap down the middle so that when you drip oil in the ball oiler, it lands in between the two bearings, fills the cavity, and flushes out both ends. This one has a ball oiler on the end of the shaft, which actually lines up with, see the holes there. There's a hole there, and there's another hole that's down inside of this casting, and that's how the steel to cast iron contact got oiled. Now it's going to oil steel to bronze oilite bushing. So anyways, 4 bushings, one there, and 2 on the hand wheel. Everything else when I took the apron apart was real tight. I was pretty happy with all the other fits. So these are the things that see the big wear, and it's kind of a negligent thing on this lathe apron. It's steel to cast iron is never a good combination. The cast iron always loses. Okay, so I'll get it set up on the mill and show you the boring head and everything I'm going to use, and I'll probably show you how to index onto an existing hole, especially one that's elongated. And you just have to take the best average on those, but I'll show you how to set that up here momentarily. Before anything can be done, as far as halfway accurate boring, the vise, you got to break down the mill. I get the vise and everything off the table. I stone down the table and get any little nicks or dings off of it, make sure it's all nice and flat, and then you get an indicator on there. And with the spindle disconnected from the drive, you want to spin it by hand and basically sweep the table. So out in front, we're at 0, and then you turn it 90 degrees, and you're at 0. Then you turn it to the back, and you're at 0. And you want to make sure that the spindle is turning square with the table all the way around. And you got your tilting nod with the head. You got these 4 bolts that do the tilting. That'll send the head side to side. So we get that adjusted. In the back you got the nod, which is the nod of the head this way. So you adjust your tilt and nod and get your table known to be square with your quill and your spindle before attaching any work. Working out of a vise, sometimes when you bolt a vise to a table, the vise isn't square with the table, and if you're going to work out of the vise, you got to square to the vise. If you're going to work off the table, you got to square to the table. And it's unfortunate, but that's just the way it is. I've never met a vise that was completely parallel and didn't need to be indicated in. So before we can bolt any of our cast iron work to the table, you want to make sure that you do this. That's kind of an important step in boring. Otherwise you end up with a hole that's bored diagonally, slightly diagonally, but diagonally nonetheless, and then you're trying to line up 2 shafts and you can't get them in, and they're tight when you're done, and it can just be messy. Just spend a little extra time on it, and you'll know you got nice straight bored holes. Okay, so we've got our work bolted down to a clean table. We know our quill and spindle are square with the table. We already measured all that. We stoned off the back of these parts, get all the nicks and burrs off of it. All that's left to do is indicate over all the individual holes. We're going to be drilling or boring this one, and then this one over here. So we're going to start off with this tall one right now. So what you do is you get your last word type indicator on there, and bring your quill down. I've already set this up so it'll zero out all the way around. And what you do is you sweep the hole. So we're on 0 there. Then you turn it 90 degrees, and you check it there, and then you turn it 180 degrees, and you check it there, and then you turn it 270 degrees, and you check it there. So you're taking your indicator and actually making a sweep of the hole. And these little tiny indicators are great for this. They've got an adjustable probe, and you don't want to spin them under power. Obviously, you'll sling all the guts out of them, but you just disengage the spindle so you can spin it by hand. And with the table locked, We've got the knee locked and the X and Y locked, and we've got 0 readings on that indicator, so we know we're right over that hole. And all we do is move the table straight up and straight down and set our boring head and bore our hole. And we're back. We're done sweeping the hole. And this is the boring head I'm using. This is a knockoff Citron head adjustable boring bar. When you tighten this screw, it's got ways in it like a lathe. And then you got Gibbs screws right here, and that slides that head sideways. And this is just a standard indexable boring bar. Exact same boring bars I use on the lathe. And when it spins, you can just see the tool just turns. It's a single point cutting attachment. And I've already made one little pass, but I can get you down a little closer and see how that thing cuts. It just turns like that. And we advance the feed very slowly. We use the auto feed on it. So you engage your auto feed here, and you come over here and you set your cuts per revolution. I have it set for 3.2 thousandths per revolution. That'll advance the tool, and then you just keep advancing this screw. You see that's an educated nut. It's got increments on it. Those are in thousandths of an inch on a radius. So if you dial in 10 thousandths here, you get 20 thousandths on the part. So you need to be aware whether it's a direct reading dial or a radius reading dial. But so all these measurements on my total diameter, I have to actually cut in half. So I'll get this thing running and shoot a little bit more for you. And here I've advanced the tool 10 thousandths. So on a diameter, that's a 20 thousandths cut. And as you can see, the auto feed is just slowly pulling it down. So it's pretty simple after you're set up to bore a hole, and you can do it very accurately. And this is the best way to make a truly round hole. And placed where you want it. Single point cutting ignores any previous holes. It doesn't try to follow a previous hole. It just plows through it. And the only other thing you could do is ream it when you're done with a very nice finishing reamer. But that's it. I got this to do 3 times, and we'll have 3 holes bored. Pretty simple after you get set up. And we're back. We got our hole to size, and what I use to measure that is snap gauges, these little telescopic snap gauges, and then a micrometer. And there's my final micrometer reading. That hole is 2 thousandths under the actual bushing OD. And this is the one where we want just a little short bushing up front, because we've got an oiler out here. So we're creating a gap. We're putting a long bushing in the back and a short bushing in the front. And I made this little bushing piece. And it's pretty simple while it's on the mill. You just get it in there like that and get it started after you get all your chamfers and everything. Take your boring bar out of your boring head. And then the bottom of the boring head is nice and flat. So you just bring the quill down and bump it in the bushing. And just give it a little bit of a push down until you stop, and bushing in. And you basically use it as a press because everything's already all squared up. You already know the bottom of your boring head's flat and square, so it'll just snap right in there. And then what we've done with that 2 thousandths is we put a radial load on this bearing, and we brought the ID of the bearing in 2 thousandths of an inch, so it's going to fit on the shaft quite a bit tighter. And we can Scotch-Brite wheel it and hone it to fit, so it fits nice and tight. But I've got all the other holes to do, but I just thought I'd show you that one, how it gets fitted up. I'm not going to shoot any more video until we got everything bored and all the bushings in and start assembling. And we're back, and I've got all my holes bored. And we're got bushings in here and here, and in where the hand wheel goes. This is the one where I intentionally created a gap between the two. I actually put 2 bushings in there because that's such a long casting, a long boss there. So there's a ball oiler right there. All you do is take an oil squirt can and push in that ball and to oil the bearing. But right where that ball oiler is, I created a space between the two. You can probably see down in there. So we've got a gap in there for that oil to fill and to wash out both directions. So that one had to get that. This one is using this shaft here, and they got a ball oiler on the end right there, and that lines up with these 2 holes here. This whole shaft is drilled for the oiling system. And all you see is the end of this shaft through this hole. I'm going to actually put an indicator mark on it. I'm going to put one little punch mark so that when you can turn the carriage and get these holes facing down to oil it. Because if they're facing up, you're trying to oil from the center and you're trying to pour oil uphill. So I'm actually going to put an indicator mark so that I know which way is up on that shaft so it can get oiled properly. But on this shaft, the bearing here for this hole is this one, and then the opposite one over here is the one in the other case half here. And that's actually the pinion. This is the pinion gear that drives the carriage. So this one's under power a lot, and it stands to reason why that was worn out. This is just a hand crank wheel to move the carriage back and forth. So this one's really not under power. This one wasn't that bad, but I went ahead and bushed it while it was out and on the mill. This is the one I really wanted to get. So I'll get it put together, and it's probably going to be really tight at first. I'm just going to assemble it with some lubriplate, white grease, lithium based, and see if I can get it run in and see how smooth we can get it and see how much play we got out of it. Okay, here we go. And here we're back. And I've got a dial indicator on there again. And I don't really remember when we first started off. I don't remember the numbers we had. They were pretty major. I'm going to pull this shaft and try to move it in the same direction as the indicator's in. There's positive 1,000, and I'm pushing, and about a half a thou negative. And I'm moving back and forth right now. So it's got about 1 thou of play in that bushing. This is where we got 1 bushing in here. Got another one over here on this other side. And then, of course, we did the hand wheel with the 2 with a gap in the middle. And the whole assembly is just silky smooth. It's real nice. And no backlash. I can't even feel the backlash in the gears. So it's there was a noticeable improvement. And it'll just help the overall feel of the machine. I mean, I've been running this machine for a long time, and I know how to work around the backlash. All machines have it, and you just learn to deal with it. And some have more than others. So, I don't know, maybe I'll start getting inaccurate now that I've got a machine that's tight. I'll have to relearn everything. But that's the end of this. I'll stick it back in the machine and show you how much play we got in the hand wheel when it's all done. The only thing that could leave us any backlash now is the difference between the pinion gear and the rack that's on the machine, if there's any wear there. This pinion actually didn't look too bad. It looks pretty darn clean. So let me get it back on the machine and we'll shoot the last little bit. Okay, we got everything all installed. And as I thought, we've got very little movement on this thing. About an eighth, just like an eighth of an inch, or maybe a 16th of an inch. But gosh, it's just not much. And it feels very tight and nice. That's just the way it feels like it should feel. And there's our bushing installed in there. And the feed likes it too, because we, if you recall, I mentioned earlier that I rebushed this, the lead screw here at this end, and I took the gearbox apart. And there's another bushing right behind this collar. And I rebushed that, and I checked all these other bushings in the gearbox, and I just cleaned the gearbox up. Each one of those holes and dowels represents a gear and a feed rate of the lead screw. And that lever there reverses the lead screw. It'll run the lead screw in a forward or reverse direction. So the way it works is you just start the machine and get the lead screw spinning. And see, now your lead screw's turning at the speed based on your primary gear and your secondary gear here. And then you've got two ways to engage the feed. This is a simple clutch on the bottom, and this is going to operate this hand wheel and run the carriage at a steady feed rate based on what gears you've selected. And then you can switch gears here, and this will actually run this feed. See, that's running your X. You can run your X or your Y, either one. And the other way is this is what's called a half nut, and it's used for threading. You see my threading dial is just slowly running, and this is to time the carriage to the lead screw for cutting threads on the lathe. And what this does, this doesn't go off of a clutch. This actually clamps. It's called a half nut. It's a nut that's in two pieces that when it clamps down on that lead screw, it just follows the lead screw no matter what. We've got the clutch in a neutral position here, and now we're ready to engage the half nut. And see, that advances much faster, and you are pinned solid to the lead screw with no clutch or anything, so there's no chance of any slippage that would screw up your threads if you were making a thread. But that's the end of this project. It's running real smooth. I've got gear oil in it and all cleaned up. Pretty happy with the results. It's nice to have a real tight carriage. It just makes for a smoother machine, and your accuracies get a little tighter. This is the kind of stuff I found in the carriage when I took it apart. This stuff gets everywhere, and it's just, and we call it swarf, but it's just metal shavings. But that's the end of that, and I'm fairly pleased with the results.